Well, our final section in the counting chapter is on something called combinations. Very much related to permutations. The formula for it will look very similar. And so we're going to start off by reviewing a little bit, including some review of permutations before we dive into what the official definition of a combination is. So recall, a subset of distinct elements taken from a set. So basically you have a set and you just take some of the items from the set and then arrange them in a specific order. That is a permutation. Suppose, for example, 3 people have to be selected from a class of 20 students. One will be the president, one will be the vice president, and one will be secretary. Those 3 people with their assigned offices would be one permutation. Specifically, they could be considered one of the permutations of 20 people taken 3 at a time. So you had 20 in the group, 20 students, and not only are you just randomly choosing 3 people maybe, but you're taking those 3 people and you're calling one the president. Maybe I'll call that number 1. And number 2, the vice president, and number 3, the secretary. It's similar to 20 people running a race. And one of them has to come in first, one of them has to come in second, one of them has to come in third. Okay, so counting how many different ways those 3 people could be selected and put into the positions of president, vice president, and secretary, that is a permutation problem. And we know that. If you had 20 people in a room, how many ways could you select? I'll put number 1 here for president, number 2 here for vice president, number 3 for secretary. How many different ways could you make the selection of president, vice president, secretary from that group of 20? Well, 20 people have the possibility of being the president. And then of the 19 remaining, you'd get the vice president. And of the 18 remaining, you'd choose one for the secretary. So whatever this number is when you multiply it together, that's how many permutations you have of 3 people taken from a group of 20. Okay, here's a brief, very simple introduction to combination. But if the class simply needs 3 officers with no titles, no vice president, president, secretary, just 3, call them maybe equally weighted people, order doesn't matter in that case. In this case, the 3 people are a combination. Specifically, they would be one combination of the 20 people taken 3 at a time. So, in the permutation, let's say you took person A, B, and C. Well, one permutation, that you can make many permutations from those 3 people. It could go A, B, C, A, C, B, B, A, C, B, C, A, C, A, B, C, B, A. Those are all different permutations. But in a combination, if you had A, B, and C, they're just in the collection. There's not one that's bigger, better, faster, stronger than the others. They're just all 3, in this case, officers. So if you choose A, B, and C, there's only one way. They're all equal officers. Order makes no difference whatsoever. All right, number 2. Let's consider the 4 set, which remember just means a set with 4 elements in it. I called it capital X. I didn't even have to give it a name if I didn't want to. We got this 4 set with A, B, C, D. How many permutations of size 2 does X have? Well, let's write them out. Actually, we already know, I think. How many would it be? If it's a permutation, order matters. How many of those 4 could end up being in this position? 4 of them. How many of them could end up then being in this position? You could choose any one of the remaining 3. So we know it's going to be 12. But let's write them out. It's a little painful, but let's do it. And when you're doing this, if you're not sure what the answer is and you start writing them out, make sure you're putting some kind of a method to your madness. For example, I'm going to write AB as the first permutation. I chose the first two elements and in that order. And then I'm going to choose all of them that start with A. AB, AC, AD. That's all of the permutations of two letters where they start with an A. And then maybe I move to B. B could go BA, because remember it's a permutation order matters here. BA, BC, BD. And then I'm going to move over to start the one starting with C. CA, CB, CD. And now let's move over to the one starting with D. DA, DB, DC. Okay, so now do anywhere, let's see what I've got. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's it. We methodically went through all 12 of them. You don't have to write them in this order, but it's nice and easy. For example, to start with the 3 permutations that start with A, then the 3 permutations of 2 elements that start with B, and then C, and then D. Okay, same problem, how many combinations of size 2 does X have? Combinations. That means order doesn't matter. In a combination, this and this, they're the same, right? Because it's the set of 2 elements containing A and B. Order doesn't matter. So, and let's go ahead and write those out. The combinations, and maybe I'll put 2 dash combinations. The combinations of size 2 would be AB, AC, AD, starts off the same, AB, AC, AD. Then when we get to B, I'm not going to go back to BA because I've already got AB. So I'm going to go B and I'm going to match it with the things ahead of it there, BC, BD. And now I'm done with with all of them that have an A or a B. Now I move to the last one and it's CD. And notice we've got only half as many. And that makes sense because if you reverse the order of each one of these 6, you would get a new permutation. But these are called combinations of 2 elements taken from a 4 set, this set. Okay, so this is equivalent to asking how many subsets of size 2 does X have. These are all of the subsets. Remember, a subset means you just take some of the elements out of this. If I took just A is a subset. ABC is a subset. ABCD is a subset. Actually, even the empty set is a subset. The empty set is a subset of every set. So, if you are going to choose 2 elements from here to make a subset, well, here would be 1, here's 1, here's 1, here's 1, here's 1, here's 1, the total of 6. Now, if you're writing subsets, it says write them out, you have to do it like this. That's one subset. A subset is a set, so it needs squiggly brackets. And then we would get to AC, and we would have AD, and then BC, and BD, and the last one is CD. This is the list of all of the subsets that have 2 elements, subsets of this set, capital X. So in the next video, we'll get to a more formal definition of what a combination is.